Question number 25th. Attempt either option A or B. A. The electric circuit in a clothes dryer contains two heaters X and Y in parallel. The above figure shows the circuit connected to a 230 volt power supply. When both switches are closed, the current in X is 3.5 ampere. Analyze the circuit given above and answer the following questions. First, calculate the power developed in the heater X. Second, if the resistance of X is double that of Y, calculate the current in the heater Y. Now question number 25th A. Here is a circuit. We have 230 volt source and there are then electric circuit in a clothes dryer contains two heaters X and Y. This is the heater X. This is the heater Y. And they are connected in parallel to the source. When both switches, the above figure shows the circuit connected to 230 volt. When both the keys are closed, this gets closed, this gets closed, then the current in X is 3.5 ampere. Here the current is 3.5 ampere. Means we know I equals to V by R. So in parallel the potential remains same and here current will be Ix and here will be Iy. So Ix equals to V by Rx. V same, so we can say this Rx will equal to V by Ix. So we have to calculate the power developed in heater X. So power Px equals to Vx into Ix. So X is 30 volt into Ix is 3.5. So that equals to 805 watt. This is the first part. Second, if the resistance of X is double that of Y, calculate the current in the heater Y. So here current Iy we have to find, that will be V upon Ry. So that means it is given that Ry equals to Rx by 2. So here it will be V upon Rx upon 2, that will be equals to V upon Rx into 2. This 2 gets multiplied and this Ix is already given to you how much? 3.5 ampere. So that means this Iy equals to twice of V by Rx, which is Ix. So twice of Ix, so that will be 2 into 3.5, that is 7 ampere. Just once again we'll explain. Here is the source of 230 volt. There are two dryers having resistance X. They are dryer X and Y. In dryer, when these keys are closed both, then the current flowing through this dryer X is 3.5 ampere. So we are asked to find out the power consumed by the dryer X the power consumed is always V into I. So Px will be equal to Vx into Ix. Since the voltage for these two is same as they are in parallel, so it will be 230 into the current is 3.5 ampere, that will be equal to 805 watt. The secondly, one is given in the question, that the resistance of this Y dryer is half of the resistance of the X dryer. That means Ry equals to Rx by 2. And we know I equals to V by R. So Ix will be equal to V by Rx. That way you can calculate it, although it is not required here. So we know Y will be similarly V upon Ry. So Ry can be replaced by R by Rx by 2. The V upon Rx by 2. This 2 gets multiplied here. Then twice of the V by Rx. And since V by Rx is Ix, which is 3.5 ampere. So we can say Iy equals to 2 up into V by Rx, that is 2 into Ix, that is 2 into 3.5, that is 7 ampere. Question number 25th or part, that's part B. The above figure shows two resistors X and Y connected in series to a battery. The power dissipated for this combination is P1. When these resistors are connected in parallel to the same battery, then the power dissipated is given by P2. Find out the ratio of P1 and P2. Now question number 25th or part, that is B. The above figure shows two resistors X and Y having value R and 2R, and they are connected in series to a voltage source. The power dissipated for this combination is P1. So P1 is the power in series, and when these resistors are connected in parallel to the same battery, that means when they are connected like this, this is X and this is Y in parallel, then this is R and this is 2R. Then the power dissipated is P2. P2 is when they are parallel. So in case of P1, when connected in series, so R series will be equals to R plus 2R, that is 3R. So P1, that is P series, will be equal to V square by R series. That is, if suppose this is the V, so this is V square upon 3R. Now R parallel, when they are connected in parallel, then R parallel will be equals to product upon sum R into 2R upon R plus 3R. This is the shortcut to find out the resistance of the two resistors connected in parallel. Product upon sum. If you do it like this, 1 by R dash is equal to 1 by R plus 1 by 2R here. So you get resultant LCM 2R, and here you get 2R plus R. So just reverse it. It is 3R upon 2R. It is 2 plus 1, that is 3 upon 2R. So R dash will be equals to 2R upon 3. So here it will be 2R square upon 3R. So when they are connected, connected in parallel, so the resistance in parallel will be equals to product upon sum R into 2R upon R plus 2R, that is equal to 2R square upon 3R, that is equal to 2R upon 3. This is the shortcut way to find out the resistance, equivalent resistance. When there are two resistors, then you have just to find product upon the sum. Just like here, you can just see 1 upon R dash equal to 1 upon R plus 1 upon 2R. So you will get the LCM 2R, and here you get 2 plus 1, that is 3 upon 2R. Just reversing it, that is equal to 2R upon 3. So you will get the same answer. So here P2 will be equal to P parallel, that is V square by R parallel. That means V square upon 2R by 3. So that will be 3 V square upon 2R. That means if you find out the P1 by P2, so that will be equals to V square upon 3R upon 3V square upon 2R. So just reversing them, you will get 2R upon 3V square. V square by 3R और 3V square upon 2R है, तो इसको V square by 3R आ जाएगा, इसको पलट देंगे 2R by 3V square. So this V square will cancel out, this R will cancel out, and you will get 2 by 9. So that means P1 ratio P2 will be equals to 2 ratio 9. इसको एक बार फिर से देखेंगे कि जब ये सीरीज में थे तो रिजल्टेंट रेजिस्टेंस क्या हो जाएगा, ऐड हो जाएगा 3R हो जाएगा, और पावर क्या होती है V स्क्वायर बाय R होती है, तो V स्क्वायर बाय 3R हो जाएगा. Then it is parallel, so then resultant or equivalent resistance will be product upon sum, that will be 2R by 3. So R parallel and power P2 that is in parallel, that will V square by RP, that will V square upon 2R by 3. So this 3 goes up, 3V square by 2R. Now we have to find the ratio of P1 and P2. So P1 upon P2 will go to V square upon 3R and divided by 3V square upon 2R. Just reciprocal, तो V square upon 3R, इसको reciprocal करेंगे तो 2R upon 3V square. V square will cancel out, R will cancel out, and you will get 2 by 3 3 is 9. So P1 is ratio P2 is equal to 2 ratio 9. Question number 31A. What is the fundamental difference between hypermetropia and myopia in terms of the optical experience of a person? Now, question number 31A. What is the fundamental difference between hypermetropia and myopia in terms of the optical experience of a person? So, as far as the myopia is concerned, so here the person can see nearby object distinctly and cannot see distant objects clearly, like this. So he can see these objects, nearby objects, but cannot see distant object. So this image is not formed at the retina. So that's why the distant object, this is the nearby object and this is the distant object. So it is not able to see. Whereas hypermetropia, the things are reversed. This person cannot see nearby objects but can see distant object clearly. This can be like this. This is the eye, and distant object means rays will be coming parallel. So they meet at this, but the nearby the image is formed beyond the retina, so that's why these are not visible to the person. In this case also you can make a diagram like this. The parallel rays, they will meet early, so this will not be visible by this person. So this is the difference. Here, the person, in case of the myopia, the person can see nearby objects very clearly, but distant objects cannot be seen. In case of hypermetropia, the distant objects are very much clearly seen, but nearby objects are not being seen by this kind of person who is suffering with this defect. So these are the basic differences. Question number 31b. The diagram below shows a special case of an eye defect. First, what is the defect that is shown in the figure? Second, state one cause for such a defect. Part 3. Explain with reason if a concave lens can be used to correct the defect. Question number 31b. And the question is, in this diagram, an eye defect, this is one of the case of the eye defect. We have to answer what is the defect that is shown in this figure. So what is that defect? And state one cause for such a defect. This is the second part. And the third part, explain with reason if a concave lens can be used to correct the defect. You know, this defect can be corrected by concave lens or not. So here, as in the previous part 31a, we have very clearly explained that this is a defect which is not able to see the nearby objects. So this is hypermetropia. So the first part is the case of hypermetropia. So it is the case of hypermetropia. Now the second is, what is the cause of the defect of this? So the first cause is the focal length of the lens. The focal length of eye lens is increased. Focal length of eye lens is increased. And the second reason is that the eyeball shrinks. Means instead of being the eyeball like this, it just shrinks. So if the eyeball will shrink, still the point of image will be fall outside the retina. And if the eyeball is okay, the focal length is enlarged, so then these rays will be converged at the larger distance because the focus has been large. So it will still be beyond the retina. So these are the two regions due to which this kind of defect occurs. And the third part is explain with reason if concave lens can be used to correct the defect. So here you see we have to make this image at the nearer distance. That means if you use here a convex, if you use here a concave lens before the eye lens, then what will happen? These rays will further diverge. And the eye lens has to converge them at more large distance. So this cannot bring it this way. Whereas if you take the convex lens before that, so what will happen? This will converge it and the eye lens will be able to further converge at the retina. So this way the correction can be done only by the convex lens, not by the concave lens. So the answer is no, since concave lens diverges the rays, so it will convert, so the eye lens, so it means the eye lens, so the eye lens will converge the rays at a point farther than the earlier one. So once again we can just see here the person is not able to see, or that means the image is not formed on the retina but it is formed beyond the retina. That means the person is not able to see the nearby objects, and this kind of defect is called hypermetropia. So here the case is of hypermetropia. Second is, what are the cause for that? The cause for that is either the focal length of the eye lens is increased, that is why the lens is able to converge it at a beyond retina, that means at a large distance, that is large focal point. Or focal length is correct but the eyeball, instead of being this, it shrinks. So that in that case also the image will form beyond the retina and the person will not be able to see. The third case was, can it be corrected with the help of the concave lens? So the answer is no, it cannot be corrected by the concave lens because the concave lens has the property to diverge the rays. These rays were moving like this, but the concave lens will further diverge it, which will make the lens difficult to converge at the near point. Rather, to say, it will converge these rays at the farthest point than the earlier one, farther point than the earlier point. And if you take the convex lens, it is for your knowledge, because in the exam maybe question different. So for the in case the convex lens is used, so the property of the convex lens is to converge the rays. That is why it will make them here instead of here, it will make here. So the eye lens will have the opportunity, or it will have easy to, or it will be able to converge these rays at the near point, that is at the retina. So this way it can be corrected.